So the next theorem that we're going to prove is also not in your packet, and it's very, very similar to the congruent supplements theorem that we just proved. And it's the second theorem we're going to prove, and it's called the congruent complements theorem. And you're going to see that the structure of the proof is very, very similar to the proof that we just saw. First, let's define what the congruent complements theorem is. It states that if two angles are complements of the same angle, or of congruent angles, then the two angles are congruent. Okay, so this is almost saying the exact same thing as the last theorem, except we're talking about if we have two angles that are each complementary to the same angle. Instead of being supplementary now, they're complementary, but we have the same result. If two angles are complementary, each of them to the same angle, then those two angles are also necessarily congruent. So let's see what we're given here. Here we would be given that A is complementary to B. Should say angle A is complementary to angle B. And I should also say that we're also given, let's say, angle C is complementary to angle B as well. So here you've got both angle A and angle C are each complementary to the same angle. And then to prove, what we need to prove here is that proves that angle A is congruent to angle C. Let's go ahead. Let's do our proof. We have our statement. On the left, we have our reason. On the right, go ahead. And first, what do we always do? We write down our givens. So we can always do that at the beginning. So we're given that angle A is complementary to angle B. That's a given. And we can write down also that angle C is complementary to angle B. That also is a given. So now we'll go ahead and, rather than what we did in the last proof, use the definition of supplement, we're going to use the definition of complementary angles. So we can state that the measure of angle A plus the measure of angle B is equal to 90, because that is the definition of complementary angles. Okay, and we know from number one that A and B are complementary. Similarly, we can say that the measure of angle C plus the measure of angle B equals 90, also because of the definition of complementary angles. And just as we did in the previous proof, we can now set the left sides of these two equalities equal to each other, since each of them is equal to 90, and then either by transitivity or by substitution, we can say that the measure of angle A plus the measure of angle B equals the measure of angle C plus the measure of angle B. And this would be either substitution or the transitive property. You could use either reason. Okay, so we've just set this segment this expression equal to this expression because they're each equal to 90. And just as we did in the last proof, we can use the subtraction property of equality to subtract out the measure of angle B from both sides, leaving us with the statement that the measure of angle A equals the measure of angle C. And that means, as before, that angle A is congruent to angle C by the definition of congruence, or in this case I'll say definition of congruent angles, which is a little more specific because it's the specific definition of congruence that applies to angles. I could have used this reason also in the last proof as well.